Hello and welcome to the Unifire YouTube channel. Today I'll be talking about the new fire protection requirements for Ro-Pax weather decks. These are the SOLAS II-2 regulations and the FSS Code. My name is Roger Barrett James. I'm the Executive Vice President and General Counsel of Unifire AB of Sweden. We were partners in the weather deck fire detection and fire suppression work packages in the EU-funded LASH FIRE research project. I was involved in developing reports on weather deck detection technologies, fire monitors, and also autonomous fire monitor systems for weather deck protection. I co-authored LASH FIRE reports on the topic, and I am involved in real-world design and deployment of weather deck fire suppression and detection systems on Ro-Pax vessels. So here's a quick roadmap of what we'll be talking about. First, we're going to talk briefly about the problem and why these regulations matter. Next, we'll look at the new rules as they apply to ships built on or after January 1st, 2026. Then we'll turn to the rules as they apply to ships built before January 1st, 2026. And then, going beyond compliance, we'll have a look at the LASH FIRE study and lessons learned from that can add to best practices and which may become the basis for further regulations down the road. So the problem, why does this matter? When it comes to firefighting, time is of the essence, and fires will grow exponentially quickly given the right fuel and air environment. So what the time it typically takes for a crew to react on a ferry ship to a fire will be somewhere between approximately 5 and 12 minutes from the time the fire is detected and located. So to give you an idea of what 5 minutes, say more or less a best case scenario looks like, you're about to see video here from large scale fire tests that were done in Norway in the LASH FIRE project. And this was a fire simulated on a weather deck with a 5-minute pre-burn to see what does the fire look like at 5 minutes that it might take a crew to get to in a best case scenario. And this is what a 5-minute fire looks like. It's an absolutely massive fire. So the point is you really need to detect a fire right away, and you need to start suppressing it immediately, because this will just continue to grow extremely quickly, especially on a large weather deck fully packed, as is typically the case. This is what it looks like. Now, if you have cars or one of those lorries on fire, that can spread extremely quickly. So you really need to get to it immediately. And to do that, you're going to need to detect it, and you need to have fire monitors that can properly reach and suppress that fire. So let's look at the new rules for new build ships built on or after January 1st, 2026. So first of all, these rules apply to ro-ro passenger ships that have weather decks intended for the carriage of vehicles and carry more than 12 passengers and are engaged in international voyages. So the new SOLAS requirements, and note at the bottom of every slide I have the specific reference to the section where the rules are set out. So a fixed fire detection and alarm system is required for the entire vehicle area of the weather deck, and it must be capable of rapidly detecting a fire anywhere on the area. The detector type, spacing, and location are to the administration's satisfaction, and the system must account for weather conditions, cargo obstruction, and other relevant factors, and different settings are permitted for loading and unloading versus voyage to reduce false alarms. So this standard is performance-based. It doesn't tell you what type of detector you need to have or how many or where to put them, but it needs to work under the conditions of a weather deck. Next, fire extinction, meaning monitors. So SOLAS II-2 paragraph 6.2.1 requires fixed water-based fire extinguishing system based on monitors shall be installed to cover weather decks intended for the carriage of vehicles. And here, monitors is a term of art, meaning robotic nozzles, or water cannons. And the monitors shall comply with the Fire Safety Systems Code. So note here, this is going to be prescriptive. They're going to tell you exactly what has to be done, unlike the detection system that just says performance. So fire extinction. Now we're turning to the FSS code requirements, and it says the protected area, you have to protect the entire length and width of the weather deck intended for the carriage of vehicles, plus you need to also reach the superstructure boundaries up to 8 meters horizontally from the vehicle storage area or the next vertical boundary, whichever is less. Next, if there are any gaps in what needs to be the protected area, gaps in the monitor coverage, then those gaps, say for example, in this diagram, you have an area here the monitors can't reach. Those must be protected by nozzles that provide 5 liters per minute per square meter of the protected area. Next, monitor placement. So each monitor must be located outside the area it protects and placed in a safe position with access not likely to be cut off in the case of fire. Typically on a weather deck, that means it's going to need to be remote controlled, although that's not required. Positions must allow unobstructed coverage with vehicles stowed to maximum deck capacity. So again, as a practical matter, that means you're going to need to get them up high so that the water streams can reach all areas of that weather deck, even when loaded with lorries. Next, you have to plan for 75% of what the manufacturer says the reach will be at a given flow and pressure in still air conditions. So when you look at the manufacturer's flow and reach charts, those are based on still air conditions. So you have to back that off by 25% for your planning purposes. So in this example, if according to the manufacturer, the reach is 50 meters at whatever given flow and pressure you're designing for, then the coverage must be planned at 75% of that, or 0.75 times 50 meters, which is 37.5 meters. Next, the monitor capacity. So each monitor output must be at least 1,250 liters per minute. So a standard so-called 2-inch monitor, meaning a 2-inch pipe diameter or 50 millimeter pipe diameter, that will provide up to 2,000 liters a minute approximately at 10 bars of pressure. So standard 2-inch monitor will meet this minimum requirement. But there's also a density requirement, meaning the combined capacity of all the monitors must provide a minimum of 2 liters per minute per square meter of the protected area, and even distribution of water shall be ensured. So what does that mean? To give a quick example, if we have say a 30 by 50 meter area that needs to be protected, so that means that's 1,500 square meters, and you need 2 liters for each square meter. So you multiply 1,500 by 2, that gives you 3,000 liters a minute minimum to cover a 30 by 50 meter area. You could achieve that with two 2-inch monitors like this, each flowing 1,500 liters a minute or more. That'll give you the minimum 3,000 liters per minute. Next, structural fire protection. And I throw this in. This is not really about the monitors or the detection, but it needs to be taken into account in the planning of the weather deck. Appropriate arrangements shall be made so that a fully developed fire on weather decks intended for the carriage of vehicles does not endanger stowage areas for survival craft, embarkation stations and assembly stations, including access to these, and accommodation spaces, control stations, and normally occupied service spaces in superstructures and deck houses adjacent to the weather deck. That concludes the requirements for the fire detection and fire extinguishing on weather decks for ships built after January 1st, on or after January 1st, 2026. Now we're going to turn to the rules for ships built before January 1st, 2026. Note, compliance deadline is not later than the first survey after the 1st of January 2028. So all ships built before January 1st, 2026 need to be in compliance with the rules that I'm about to present by January 1st, 2028. So, fixed water-based fire extinguishing system based on monitors shall be installed to protect weather deck areas intended for the carriage of vehicles. Monitors shall be located to ensure unobstructed protection of vehicles as far as practicable, and operation shall be ensured by safe access ways or remote control, not impaired by fire in the area protected by that monitor. So a couple of things. It doesn't talk about protecting the area up to the superstructure. Also, it says here, as far as practicable. So that's more flexible. That means there's some wiggle room for interpretation. Next, the capacity of each monitor shall be a minimum of 1,250 liters per minute, just like the new build ships. And the administration may permit lower flow rates where the required rate is not practical given the ship's size and arrangement. So again, there's some flexibility to allow for alternative arrangements if the administration thinks, okay, that's going to do a sufficient job. And the administration may permit alternative arrangements for ships that already had a monitor-based system installed prior to January 1st, 2026. So again, very similar rules, but there's some flexibility built in. In terms of fire detection, there is no specific requirement. However, the International Maritime Organization's Maritime Safety Committee in their MSC Circular 1615 says, a fixed fire detection and alarm system should be provided for weather decks intended for the carriage of vehicles. And it must be capable of rapidly detecting the onset of fire on the weather deck, the detector type, spacing, and location, to the administration's satisfaction, accounting for weather, cargo obstruction, and other relevant factors, and different settings permitted for loading and unloading versus voyage to reduce false alarms. So this language is almost identical to the FSS Code requirements for fire detection on the weather decks for new build ships, but it says should be, not must be. Note, however, there is a high likelihood of potential civil liability if you don't put detectors on the weather deck. The cost of a fire detection system is negligible in terms of the cost on the ship, and yet having them could really save the ship. So in my view, it's pretty much a necessity to put them on. It is not legally required by this code, but for all practical purposes, one, of course, should have detection. That wraps up the rules. Now we're going to go beyond compliance and look at lessons from the LASH FIRE research project. So just a little bit about what this was. This was an EU-funded international research project that ran from September 2019 to August 2023. It was a consortium of 27 partners from 13 EU member states. And the study aimed to significantly reduce the risk of fires on board Ro-Ro ships. It examines state-of-the-art fire prevention and suppression technologies and techniques, and part of it was looking specifically at weather deck fire protection. So why am I even bringing this up? This study matters because it's the most recent in-depth scientific study on Ro-Pax fire safety, including state-of-the-art solutions. So the rules and regulations that I presented earlier were largely based on fire safe studies. There were two fire safe studies that looked at Ro-Ro passenger weather deck fire safety, and That's what those rules were based on. This is a more recent study and looked at really state-of-the-art systems that didn't exist during the fire safe studies. So, and these findings from the LASH fire study have been presented to the IMO and will undoubtedly be considered for further updates to the SOLAS and FSS code going forward. So it's worth having a look at, and it's also important to learn sort of the best practices. So the study looked at a wide range of fire detection technologies and tested them on board a Ro-Ro ship for, I believe, 6 months. And the study looked at flame detectors, thermal imaging cameras, video analytics, hybrid detectors, and linear heat detectors. You can read this for yourself, but the key takeaway is probably the most appropriate and effective fire detection system for weather decks would be flame detectors, followed by thermal imaging cameras. Both of those are very good solutions for the weather deck. They both have pros and cons. They can even be both provided. Flame detectors give a very low risk of false alarms. In other words, they're not triggered by heat sources. They're only looking for visible flame. They're very good at identifying visible flame and very quickly. And there are a couple of models available on the market that will also be able to give coordinates of that flame, which is crucial for a fully autonomous system, which we'll describe in a moment. Thermal imaging cameras are also very good. They do rapidly detect heat buildup. They are only looking at temperatures, but they are able to give the location information, a heat buildup, and the downside, however, is that because they're only looking at heat, they're more susceptible to false alarms coming from, for example, hot engines, hot exhaust, and so on, especially during loading and unloading. That is why the regulations that we mentioned earlier allow for different settings during loading and unloading. Note, however, if you have to turn the system off during loading and unloading to avoid false alarms, well, that may be the very time that's most risky to actually have a fire. So flame detectors are going to be immune from those heat sources during loading and unloading, and they can run all the time. Next, for fire monitors, the study recommends that only remote control monitors be used, not manually operated, where the crew has to physically get up and move the monitor around to guide it. That's putting the crew in potential risk of injury or even death if that fire gets out of control. Moreover, there should be dual coverage of all critical areas of the weather decks. So you should have any spot on the weather deck should be able to be suppressed from 2 separate monitors coming from 2 different locations. And the positioning of those monitors should seek to maximize the opposing angles of suppression to limit the spread of fire and to limit the effect of wind. It's almost always going to be windy on a weather deck. So if you have wind blowing in, let's say in this diagram from right to left, well, that's going to carry that stream farther, and it's going to carry the opposing one less far. So by having 2, you're maximizing the chances of getting very good suppression on that fire. And I'll just point out again here that these studies were based on actual fire tests, numerous tests that were done, including with wind simulations and so on. Next, the monitor should be placed at least 7 meters up above the weather deck, i.e. 3 meters above the roof level of a 4-meter trailer height. You need to get significantly up above the highest vehicles that will be on that weather deck in order to be able to get proper suppression going. Next, the study looked at the Unifire Flame Ranger fully autonomous system. And this is part of that state-of-the-art review. And fully autonomous systems provide a huge advantage, which is they can not only detect a fire, but locate that fire and begin suppressing that fire very rapidly. In the testing that was done, every fire was detected and suppression commenced in less than 10 seconds, irrespective of the position of the fire test source. And what you're looking at here, and you'll see video clips from this, but this was also a simulated weather deck, a 30 by 50 meter area of weather deck. And these tests were done fully autonomously by simply a system that's able to pair the detection with advanced aiming capabilities of the fire monitor. And the system is just able to literally triangulate the exact size and position of that fire and accurately and intelligently aim the water cannon to suppress it. Of course, manual operation is always available for the crew if they want to intervene, but these systems will start autonomously in seconds. So here you're about to see how fast the system can react. So this was reacting to one fire. Now you'll see a new fire being lit, and you'll see how long it takes for that system to have identified where that is, calculated its exact position, and suppress that fire. So in about 7 seconds is all it takes. So note, when you go from 5 minutes with that massive fire that I showed at the beginning down to just seconds, right? You're absolutely getting to that fire when it's still small and easy to control. So that's the whole point of the autonomous system, and that's recommended by the LASH FIRE study. There was an onboard demonstration done of this Flame Ranger autonomous fire monitor system. And in that, there were 12 separate fire tests placed at random locations on the weather deck of the Stena Scandinavica. In each test, the fire was rapidly detected and its three-dimensional size and position were accurately confirmed. The autonomous and effective fire suppression was achieved without any human intervention. And critically, in all 12 tests, each fire was extinguished autonomously in less than 15 seconds. Moreover, again, these can be remote controlled, and the study confirmed the viability for use of autonomous systems on Ro-Ro weather decks. And again, there's reports at lashfire.eu, and you can see the report D10.2 that goes over this onboard demonstration. There are many other reports available, so if you're someone who's involved in the planning of fire detection systems and the fire monitor systems, please feel free to reach out to me at Unifire. You can contact me at contact@unifire.com, and I can provide those reports, which are very important to look at when looking at which detection system and which monitors and how to place them and so on. So thank you very much. Again, if you have any questions, please contact me, and we look forward to seeing you in our next video. Thank you.